Hi guys, this is the back EMF test circuit that we did the other day with some revisions. What I've done is I've ensured that the coil is on the common contacts of the relay. Before I had the power feeding the coil coming from the common contacts, and then the coil was set to the normally open contacts. So I've switched those now so that the center contacts on this particular relay are, there's 6 contacts for the connections. And we have the center ones, there's one here and one on the other side here. Those are the commons. Then the next set of contacts is the normally closed contacts. And then the next set is the normally open contacts. So what I have now is I have ground here connected to the normally open contact on this side, and I have B+ over here connected to the normally open contact on this side. And then we've added this black wire right here, which is coming off of the normally closed contact. So then the commons goes directly out to the coil. Okay. So there's our coil windings, and so the commons on each side, go to the coil. The coil is connected to the commons. Each side of the coil. So also connected, I should say though that the coil, the common on this particular side, on the ground side, goes through this diode and then out to the coil. Okay, so the common on this particular side goes to the anode of this diode. The cathode goes out to the coil. Now, also on that common is the LED, the anode of the LED. Okay, so then I've removed the current limiting resistor, and I've put in another diode in series with the LED, and the reason for that is because the reverse avalanche voltage of the LED is lower, and we were definitely getting some avalanche on the last test, and so a portion of the lighting that we were seeing on the last test, possibly even all of the lighting we were seeing on the last test, could have been caused by the avalanche voltage. So I wanted to repeat this test with this other diode in there and show the difference. So we have some test points now. We still have the 24 volts B+N, and we still have the reference, the ground. We're still using the car battery, and we're still using the UASA in series. So another thing I've added is this little test probe. It's just a regular automotive test light with a 12-volt bulb inside that I'm using as a test condition. It's connected to that series diode. So if this light's going to conduct, this LED, if it's going to conduct, it has to go through this diode and through this test probe. So wherever I touch this test probe, that's where the current from the back EMF is going to be flowing. It's going to flow through this diode, and then through this test lamp to the test point. Okay, so I'm going to label these on the schematic as test point A, which is B+, test point B, which is ground, test point C, which is the other side of the coil on the normally closed contact. So when it de-energizes, then we'll be seeing the other side of the coil on this black wire. Okay? And I've also got here the earth ground from my scope probe. It's just floating here, but we'll use that as a reference to earth ground. Okay? And the control circuit is the same as before. We still have our little read relay, and we're still going to drive it off of the Whippy Maggie. Okay, so let me go ahead and spin that up and get that flying here. And right now we've got the test point connected to nothing. So first we'll go to test point A, and we'll see that the LED is lighting up. So test point A, B+, it's lighting up. Then we'll go to test point B, and we see again it's lighting up. Then we'll go to test point C, the other side of the coil. We'll see that it lights up really well because the coil is our source. And then we will go to earth ground, or I'll attempt to anyway. And we got nothing. Nothing at all. Interesting. Or should I say, no! Let's spin that up again. Try that earth ground again. Nothing. So evidently the ground plane on our battery is sufficient to completely and utterly circumvent any RF connection to Earth, while providing a connection both to B+ and B-, even though the coil is isolated by the relay contacts. Okay. Now I'd like to also take point C, and I'd like to show the difference. To do that, I'm going to put a jumper on here so that I don't have to hold this. Okay. So now it'll light up all the time. Alright, so essentially our connection now through the jumper is going to test point A, which is B+, and we can see our light lighting up. Okay? Now what I'm going to do is I'm going to take test point C and I'm going to ground it. And I want you to see the difference . There's not grounded, there's grounded, not grounded, grounded. So there is intensity level, a difference in intensity level by grounding the other side of the coil. It provides a better conductive path, and we're not relying on that spatial path between the battery negative and that particular wire, or the coil itself in the electromagnetic realm. So I will show that on the schematic as well. You know, the preferred position for that test point C to be grounded provides a better path and routes that to B+. And of course, if we went to B-, then we have a larger voltage drop across the diode. We're just wasting that energy right now, just dumping it straight to ground right through the diode. So, alright, now I also want to show, which I didn't do last time, was the forward avalanche drop. So I'm going to show that now. Engaged, disengaged. Engaged, disengaged. Engaged, disengaged. Okay, so relay closed, open. Coil on, off. on, off. Okay. So, you can definitely see, or at least I can here, that we are getting some of that. Okay? I'm out of time. Catch you later.